We are at the bottom of page 15 where it says part B, oxidation reduction reactions. So I want to talk about why we dealt with double replacement reactions separately from the rest of the reactions. In a double replacement reaction, your chemicals all start as ions. So for example, if we react the compound NaCl, which is an ionic compound, with the compound barium bromide, which is an ionic compound. Okay, when we react these two, everything is already existing as ions. When they formed compounds, when sodium and chlorine joined up, a transfer of electrons happened. Sodium actually gave some electrons to chlorine, which chlorine gladly took. That's how they formed this ionic compound. As a result, that is where those charges came from. So remember that sodium gave an electron to chlorine, and as a result, sodium formed a +1 charge, which is why group 1 on the periodic table, all of those elements form a +1 charge. Chlorine took that electron, formed a -1 charge, and that is how this compound formed. Okay, the positives and the negatives attracted to each other. So because we started with all compounds, everything was already an ion. So when we reacted them together, the ions basically split up, mixed themselves up, and then reformed new compounds. So sodium joined up with bromine, and barium joined up with calcium. The charges do not change in the process. So sodium was +1 over here, sodium is +1 over here. Bromine was -1, stays -1. Chlorine was -1, barium was +2. Okay, so the charge from one side of the equation to the other did not change because we didn't do any actual changing of elements or compounds. We just broke them apart and put them together with a new puzzle piece. Okay, so in these reactions, the chemical reaction part of it is simply the combining of new atoms or new ions with each other. In the remaining types of reactions, which include the synthesis reactions, the decomposition reactions, the single replacement reactions, and the combustion reactions, in those reactions, a little bit more happens, okay? We are not just dealing with compounds, meaning not everything is an ion to start with. For example, in a synthesis reaction, where we start with 2 elements and create a compound, on this side, they are not ions, okay? Because an element from the periodic table, before it joins up with another element, does not have to gain or lose electrons. So for example, if element A was sodium, when sodium is by itself and there are no other atoms connected to it, it does not have a charge, okay? Even though it's located in group 1, that charge that we list for group 1 is only the charge it has when it is part of a compound, okay? Because they don't need to gain or lose electrons unless they want to bond to something else. However, once sodium becomes part of a compound, it has to transfer electrons to the other atom, and that's where it will form a charge. The same thing will happen with this element. So if this element was chlorine, in order to become part of the compound, it's going to need to gain the electron. So the takeaway here is that elements, when they exist by themselves, do not have a charge. They are neutral. When they are part of an ionic compound, that is when they have a charge, because they have either gained or lost electrons to become part of that compound. Okay, if you think of it as a guy and a girl dating, okay, the girl's walking around, she really doesn't care what anyone thinks about her because she's not interested in anyone. But then she meets a guy, and all of a sudden she puts on lots of makeup and wants to become really pretty so that she can join with that person as part of a couple. So that's where atoms are like people. Sodium is going to change to become part of the compound. And that change is that it's going to now lose an electron and allow that connection to happen. So sodium changes in order to be part of a compound, and chlorine will do the same thing. Okay, so there is a change from one side of the reaction to the other so that the reaction can take place. In a double replacement reaction, nothing has to change. Everyone just breaks apart and switches, and the charges all stay the same. So the process that happens when an element changes into an ion, or an ion changes back into an element, is called oxidation and reduction. And because the 4 remaining reaction types all involve both elements and compounds, okay, we're not just dealing with compounds, we have elements and compounds, we are going to see this change occurring, where some things gain electrons, some things lose electrons, they join compounds, they break apart, they form elements. And we need to understand how that's happening so that we can predict the products that are going to form. All right, so in these reactions, which we call in general redox reaction for reduction and oxidation, some electrons are going to be transferred, meaning it's in the example with sodium and chlorine. Sodium may transfer electrons to chlorine. Chlorine will take those electrons. Again, we call that oxidation and reduction. Atoms that lose electrons. So for example, sodium, when it turns into an ion, loses an electron. Electrons are negative. So when you lose an electron, you become more positive. We call that oxidation or oxidized. When sodium goes from no charge, I'm going to put a 0 here because a neutral atom has no charge, to losing an electron and becoming more positive, that is called being oxidized. An atom that gains electrons, for example, chlorine, as an atom is 0, but when it gains an electron, because it will gain an electron when it bonds with sodium, it becomes a negative charge. So when you gain electrons, you become more negative, and that means you are reduced. There's 2 little sayings here that help you remember this. So I'm going to explain what these are, but then I'm going to explain another way that a lot of you will find easier, because sometimes it's hard to remember that electrons are negative, and when you gain electrons, you become negative, and when you lose electrons, you become positive. So first of all, let's talk about these 2 sayings. Leo says grr, like a lion. So lions roar, grr, growl. LEO stands for lose electrons, oxidize. So something that loses electrons, becomes more positive, that is oxidized. Something that gains electrons is reduced. Again, when you gain electrons, you become more negative, and we say that is reduced. The other saying is oil rig. Oxidation is loss of electrons, and reduction is gain of electrons. If you understand the idea that an electron is negative and gaining an electron makes you more negative, losing an electron makes you more positive, this is your best method to remember it, okay? However, if you really struggle with that and you think, oh, if I gain an electron, then I become positive. If you're really struggling with that idea, this is what you need to remember. When I say the word reduce, if I were going to reduce a number, what do you think of? Getting what? Division? Reducing is division? Getting smaller, okay, getting lower. I mean, when you divide, you reduce too, but. Okay, so when you think of reducing, you think of getting lower or getting smaller, right? In cooking, if you reduce something down, you remove the liquid. So getting lower or smaller. So reducing is pretty easy because if your number gets lower or smaller, then you are reducing. So for example, if we go from 0 to -1, we have reduced the value. If we went from +2 to +1, we reduced the value. If we went from -1 to -2, we reduced the value. Okay, so if you can remember that reducing makes your number lower, then oxidizing is the opposite. Okay, it's going to make your number higher. Reduce. Charge. Gets lower. All right, and I'll show you some examples of how we're going to apply that. So if you're struggling with the rest of it, just remember that reduced means getting smaller or lower. All right, so let's look at an example of how we might apply this. But first, I'm going to introduce the term oxidation number. This is not something new. It's just we've never called it an oxidation number before. An oxidation number is how we're going to determine if something is oxidized or reduced. Oxidation numbers are just another name for the charge. Okay, so we know the oxidation numbers of group 1, group 2, group 15, 16, and 17, because they're the charge that those atoms form. So lithium's oxidation number is what? When it forms an ion. +1. Oxygen's oxidation number is what when it forms an ion? -2. Okay, so these are oxidation numbers. The thing you have to remember is that oxidation numbers are only used when the atom is part of a compound. So when lithium combines with oxygen, it forms a +1 charge. Oxygen forms a +2 or a -2 charge. But when lithium is by itself and has not joined with oxygen, does it have a charge? No. Okay. Elements that are not part of a compound that exist by themselves have no charge. So therefore, the oxidation number is 0. Okay, you don't really have a charge of 0, but we call it 0. So lithium as an element is 0. Lithium, when it becomes part of a compound, gets the charge that we know it will form based on its location in the periodic table. Okay, so the first thing we're going to do is we have to decide if we're dealing with elements or compounds, and we're going to assign oxidation numbers from there. So let's do an example together. Okay, so you might see an example like this. So these are oxidation reduction reactions. Again, we're not separating them yet into types. We're not predicting products, but ultimately we will. Right now, we just want to figure out which elements are oxidized and which elements are reduced in this process. So first of all, you'll be given a chemical equation. The subscript or the coefficients, which are these 2's here, remember we use those to balance the equation. They do not play a role in determining oxidation and reduction. Okay, so your focus is on the main parts. Okay, so you can kind of ignore those coefficients. All right. I'm going to add a step here because it helps students kind of separate in their brain what's going on, although ultimately you won't need to even think about it. So the first thing we need to do, because whether they have a charge or not depends on if they're part of an element or a compound. So we need to identify what is an element versus what is a compound. So is calcium an element or a compound? It's an element. Is O2 an element or a compound? How many of you think if it's an element? How many of you think it's a compound? How many of you don't have a clue? Okay. What is the definition for a compound? Anyone remember the definition for a compound? Okay. Very good. 2 or more different elements bonded together. Are there 2 or more different elements here? No. So then by definition, it is an element. So why is there a 2 after that oxygen? Yeah, why though? Charlie? Well, that 2 was put there because of that. This was done later. But why did we write a 2 after this O and not after the CA? Check. Nope, has nothing to do with charge when it's an element. It's a Brinkelhoff. Remember those Brinkelhoffs? If you have an element and it is a Brinkelhoff, bromine, chlorine, or bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine, you have to write that too. Okay, so it is an element, but it's a Brinkelhoff. That's why it has a 2. Okay, so element. Is this an element or a compound? Compound, okay, 2 or more different elements. All right, so that's step 1. Now, any elements that are part of a compound have the charge of their ion, okay? And the ion charge we can look up on the periodic table. So because calcium is part of a compound, it will form its ion, and calcium is in group 2. So what is the charge of its ion? Calcium forms what charge? Kara? +2. So I'm just going to write a little +2 above it right now, because we're going to label this so we can decide what's been oxidized and what's reduced. Oxygen, again, it's part of a compound here. And when it's in a compound, it will form its ion. And what charge does oxygen have when it forms an ion? Isaiah, what charge does oxygen form? Group 16. You don't know? When we were doing ionic compounds in the last chapter. No, not 6. 6 is how many valence electrons it has. -2. Okay. You guys have to know those charges. Okay, so we started out, we labeled the charges above anything that was part of a compound. Okay. Now we're going to go to our elements. When elements aren't part of a compound, do they have a charge? No. Okay. So these have not joined with anything at this point, so they don't have a charge. All elements have an oxidation state of 0. They have no charge. So we're going to write a 0 above each of our individual elements. Okay, now I'm going to draw a line down there just so you can see that there's 2 different ions in that compound. Now we have to do the little bit of math to determine if something has been oxidized or reduced. So what we're going to do is we're going to look at each of these and we're going to follow it from one side of the equation to the other. So let's look at what happens to the calcium from the left side to the right side in terms of the oxidation number. On the reactant side, the charge was 0. The oxidation state was 0. On the right side of the arrow, it becomes a +2. So we are changing the oxidation state from 0 to +2. Now let's do the other one. Oxygen goes from 0 to -2. So I'm going to work through this with both the acronyms that I gave you, and I'm going to use that little trick up there for those of you that really struggle. So first of all, let's talk about the acronyms. Leo says GER or oil ring. So here, if we go from 0 to +2, have we gained or lost electrons? If we become more positive, Kara? We lost electrons. So in this case, we lost electrons, so we oxidized. Or we could say oxidation is loss of electrons. So this is oxidized. If we go from 0 to -2, do we gain or lose electrons? We gain, because when you gain electrons, you become more negative. Gain electrons reduced or reduction is gain. So this is reduced. One element will always be oxidized and one will always be reduced. So if you have oxidized and oxidized, you did something wrong. So if you really struggle with these acronyms, here's the easy way to figure it out. We know that the one that is reduced, the charge gets lower on. So does 0 to +2 get lower? No. Does 0 to -2 get lower? Yes. So therefore, that's the one that's reduced. And by default, the other one is oxidized. Okay, so you are reducing the value from 0 to -2. That is the one that is reduced. Okay, so the result of what we just did is we could say that Ca is oxidized and O is reduced. All right, let's do another example. Leave that up top there. All right, you should be on example 2 on page 16 of your packet at this point. So here's another example on oxidation reduction reaction. It looks a little bit different. Okay, this one happens to be a single replacement reaction. The last one was synthesis. But at this point, all we are doing is identifying what is oxidized and what is reduced. There are 3 different elements in this one, okay? But we only have 2 choices, oxidation and reduction. So let's just take a look at what happens here so you can see why we only have 2 things that are actually being oxidized and reduced. So first of all, remember that coefficients don't mean anything in terms of oxidation and reduction. So if that confuses you, just cross it out. Next, we're going to identify what's an element and what's a compound, because that determines whether it's going to have a 0 charge or if it's going to have a charge based on its ion. Is zinc an element or a compound?
It is an element.
It is an element. Is HCl an element or compound? Compound. Element or compound?
Compound.
Element or compound?
Element.
Good, a Brinkelhoff, but it is an element.
Brinkelhoff.
Okay. Elements always have what charge? 0. So anything that is just an element, you're going to write a 0 over top of. Anything that is part of a compound, you use its charge based on its location on the periodic table. So I'm going to just split these up so that we can see them. What is hydrogen's charge? When it forms an ion, +1. What is chlorine's charge when it forms an ion? -1. What is zinc's charge when it forms an ion?
-2.
Other way, +2. Okay, remember, zinc is a metal, so it's positive. And chlorine, again, what's its charge? -1. Okay, subscript means nothing. Okay, we just look at the charge. All right, now we need to identify if it's oxidized or reduced based on the change in number. So let's start with zinc. So I'm going to just draw a little connector here to keep track of it. So zinc goes from 0 to +2. I'm going to do them all, and then we'll talk about oxidized and reduced. Hydrogen goes from +1 to 0, and chlorine goes from -1 to -1. So let's talk about chlorine first. Did the value change? No. So was it oxidized or reduced? Or neither? Neither. Okay, so chlorine is neither oxidized or reduced. So we're not going to write that for either of these. All right, now, again, for those of you that kind of struggle with the fact that an electron is negative, you're going to use the idea that reducing means it's going to get lower. The value is going to get lower. So let's find the one that reduced. Which one, +1 to 0 or 0 to +2, is reduced? Which one of those reduced in value? Sarah? +1 to 0, we reduce it if we go down from +1 to 0. That means the other one must be oxidized. Okay, again, if you like the Leo says GER or the oil rig, when you go from +1 to 0, you are actually gaining an electron because you are getting lower, you are adding negatives. That's reduced. You are losing electrons when you become more positive. That is oxidized. Okay, so once you have identified the one that is oxidized, you go back, you see which one it was attached to, zinc. Which one was reduced? Hydrogen. And that's what you have to do. Okay. All righty. In your packet, on the bottom of page 16, there are 6 examples. I would like you to go through those. Take your time to label your zeros, your charges, figure out what's oxidized and what's reduced. Once you have completed it on paper, you can go in and put them on page 1 of the chapter 20, part 3 class kit. Okay, page 1. Chapter 20, part 3. That's all you can do is page 1. Once you have completed this and put it in to check your work, then if you have any missing work, you can work on that for the rest of the period. Okay? Alrighty, if you have questions.